Now let's talk about an important architectural decision you'll often face on AWS: choosing between EC2 hosted databases and AWS Managed Database Services. This decision comes up frequently in real projects, and it's also a common topic on the AWS Certified Cloud Practitioner exam. At a high level, the question is simple. Do you want full control, or do you want AWS to manage the heavy lifting for you? AWS Managed Databases. AWS Managed Databases include services like Amazon RDS, Amazon Aurora, DynamoDB, and others. These services are designed to remove operational complexity so teams can focus on building applications instead of managing infrastructure. When you use a managed database, AWS takes care of many critical operational tasks for you, such as provisioning and setup, automated backups, software patching, monitoring and health checks, high availability and failover, scaling storage and compute, security updates and compliance support. For example, with Amazon RDS or Aurora, AWS automatically handles multi-s deployments, failover, and backups. With DynamoDB, AWS even manages scaling and availability automatically without you managing servers at all. When should you use managed databases? You should choose managed databases when you want to focus on application development instead of infrastructure. You need built-in high availability and fault tolerance. You want automatic backups and patching. Your database engine is supported by AWS. You want easier compliance and security management. You prefer predictable operations with minimal manual effort. This is why, for most modern workloads, AWS recommends managed databases by default. EC2 hosted, self-managed databases. On the other hand, you can also run databases directly on Amazon EC2, just like in a traditional on-premises environment. In this model, you install and manage the database software yourself. Here, you are fully responsible for installing the database engine, applying patches and updates, configuring backups, setting up replication and high availability, monitoring performance, managing security and OS-level updates. This approach gives you maximum flexibility and control, but also maximum responsibility. When should you use EC2 hosted databases? This option makes sense when you need full OS-level access or custom system configurations. You rely on a database engine or version not supported by AWS Managed Services. You require very specific plugins or extensions. You want exact parity with an existing on-premises setup. You need deep customization of performance or storage behavior. Comparing the two approaches. Think of it this way. Managed databases equals convenience, automation, reliability. EC2 hosted databases equals flexibility and control. Managed services reduce operational risk and workload, while EC2 hosted databases increase responsibility but allow advanced customization. Key takeaway for the exam and real life: for the AWS Cloud Practitioner exam, remember this rule of thumb. Use AWS managed databases whenever possible. Choose EC2 hosted databases only when specific technical or operational requirements demand full control. This distinction comes up frequently in exam questions, especially when you're asked to decide which option reduces operational overhead, improves availability, or simplifies maintenance. Let's now talk about relational databases in AWS, one of the most important database categories you need to understand for the Cloud Practitioner exam. A relational database stores data in tables made up of rows and columns, and it uses structured relationships between tables. These databases rely on SQL, support strong consistency, and are ideal for transactional workloads such as financial systems, e-commerce platforms, ERP systems, and business applications. AWS provides fully managed relational database services mainly through Amazon RDS and Amazon Aurora. The key idea here is that AWS removes the heavy operational work, so you don't need to worry about things like server provisioning, patching, backups, or recovery. Instead, you focus on building and running your application. Amazon RDS, Relational Database Service. Amazon RDS supports several well-known database engines, giving you flexibility depending on your workload or licensing needs. Open-source engines, MySQL, PostgreSQL, and MariaDB. Commercial engines, Oracle, SQL Server, and DB2. With RDS, AWS manages software patching, automated backups, monitoring and metrics, failure detection and recovery, scaling of storage. You can also enable multi-OS deployments, which automatically create a standby database in another availability zone. If the primary database fails, AWS performs an automatic failover to maintain availability. RDS is a great choice when you want familiar SQL engines, broad compatibility, cost-effective, general-purpose relational databases, minimal operational overhead. Amazon Aurora. Amazon Aurora is AWS's cloud-native relational database designed specifically for performance and scalability in the cloud. It is compatible with MySQL, PostgreSQL. But under the hood, Aurora uses a distributed, fault-tolerant storage system that separates compute from storage. This architecture allows Aurora to deliver significantly higher performance, up to 5 times faster than MySQL on RDS, up to 3 times faster than PostgreSQL on RDS. Storage automatically scales up to 128 terabytes. Supports up to 15 RAID replicas. Very fast failover, often under 30 seconds. Aurora is ideal for mission-critical and high-throughput workloads where performance, availability, and scalability are essential. Key benefits of relational databases in AWS across both RDS and Aurora. AWS provides powerful built-in advantages. Managed service. No need to manage OS patching or database software updates. High availability. Multi-OS deployments and automated failover. Durability. Automated backups and point-in-time recovery. Security. Encryption at rest and in transit. IAM integration. And VPC isolation. Scalability. Scale compute and storage with minimal downtime. How to choose between RDS and Aurora. A simple way to think about it. Choose Amazon Aurora when you need maximum performance and scalability. You run mission-critical or high-traffic applications. You want cloud-native architecture optimized for AWS. Choose Amazon RDS when you need compatibility with many database engines. You want flexibility with licensing, BIOS or license included. You're running traditional or moderate workloads. Cost efficiency is a priority. Key takeaway for the exam. For the AWS Cloud Practitioner exam, remember this rule of thumb. Relational databases on AWS are handled through RDS and Aurora, which provide managed, secure, highly available SQL databases. Aurora is optimized for performance and scalability, while RDS offers broader engine support and flexibility. This distinction appears frequently in exam questions, especially when comparing database choices. When we talk about NoSQL databases in AWS, we're talking about databases designed for scale, flexibility, and high performance, especially in modern cloud applications where data doesn't always fit neatly into rows and columns. Unlike relational databases, NoSQL databases don't rely on fixed schemas. This makes them ideal for applications that deal with large volumes of semi-structured or unstructured data, need very low latency, or must scale automatically as traffic grows. AWS provides several purpose-built NoSQL services, each optimized for a specific data model and use case. Understanding when to use each one is key for both real-world architecture and the CLFC 02 exam. Amazon DynamoDB, Key Value in Document. DynamoDB is AWS's flagship NoSQL service and one of the most important to remember. It's a serverless key value and document database that delivers single-digit millisecond performance at any scale. You don't manage servers, capacity, or patching. AWS handles everything. Data is stored using a primary key, and items can include flexible attributes, making it suitable for both key value and document-style workloads. Why DynamoDB stands out. Fully serverless and auto-scaling. Extremely fast and predictable performance. Built-in high availability across multiple availability zones. Supports global tables for multi-region replication. Handles massive traffic with minimal operational effort. Common use cases. Shopping carts and user sessions. Mobile and web applications. Gaming leaderboards, IoT and telemetry data. Real-time personalization. If you see phrases like high throughput, low latency, massive scale, or serverless NoSQL, DynamoDB is usually the correct answer. Amazon Document DB is designed for applications that work with JSON-like documents and want MongoDB compatibility without managing infrastructure. It supports MongoDB APIs, making it easier to migrate existing MongoDB workloads to AWS with minimal code changes. Key characteristics. Stores data as flexible JSON-style documents. Optimized for read-heavy workloads. Fully managed, scalable, and highly available. Enterprise-grade security and durability. Typical use cases. Content management systems. Product catalogs. User profiles. Applications with flexible or evolving schemas. If the question mentions MongoDB compatibility, JSON documents, or document-based storage, think Amazon Document DB. Amazon Keyspaces is a serverless, Cassandra-compatible wide-column database. It's built for workloads that require massive scale, very high read/write throughput, predictable performance, always-on availability. Since it's compatible with Apache Cassandra, existing Cassandra applications can migrate with minimal changes. Key benefits: no infrastructure management, automatic scaling, high availability, optimized for large-scale workloads. Typical use cases: IoT telemetry, time series data, fleet management systems, event-driven architectures, high-volume sensor data. When you see terms like wide column, Cassandra, or massive write throughput, the answer is Amazon Keyspaces. Amazon Neptune is designed for highly connected data where relationships matter more than rows or keys. It supports graph models using Gremlin, property graphs, Sparkle, RDF graphs. Neptune excels at traversing relationships quickly, making it ideal for complex connections between entities. Key strengths: fast relationship queries, optimized for graph traversal, fully managed and highly available. Typical use cases: fraud detection, recommendation engines, social networks, knowledge graphs, network topology analysis. If the question mentions relationships, connections, graphs, or traversal, Neptune is the correct choice. Amazon QLDB, Ledger Database, QLDB, is a ledger-style database with an immutable and cryptographically verifiable transaction log. It's ideal when data must never be altered or deleted without a trace. Use cases include financial transactions, supply chain tracking, insurance records, audit trails. Amazon ElastiCache and Amazon MemoryDB for Redis in-memory. These services are designed for extremely fast, in-memory access. ElastiCache used mainly as a cache, not fully durable. MemoryDB for Redis compatible with durability and persistence. Use cases: caching frequently accessed data, session storage, real-time leaderboards, microsecond latency applications. To quickly identify the right NoSQL service, DynamoDB, key value or document, massive scale, serverless, DocumentDB, MongoDB, compatible document database. Key spaces: wide column, Cassandra-style workloads, Neptune, graph relationships and connections, QLDB, immutable ledger and audit trails, ElastiCache, MemoryDB, ultra-fast in-memory access. Understanding what type of data you're storing and how it's accessed is the key to selecting the right AWS NoSQL database and to answering Cloud Practitioner exam questions correctly. Now let's talk about memory-based databases, which are designed for one main goal: speed. In traditional databases, data is stored on disk, which is reliable but slower. Memory-based databases, on the other hand, keep data directly in RAM, allowing applications to read and write data in microseconds. This makes them ideal for workloads where performance and low latency are critical. On AWS, there are two main memory-based database services you need to recognize for the exam: Amazon ElastiCache and Amazon MemoryDB for Redis. Let's start with Amazon ElastiCache. ElastiCache is a fully managed, in-memory caching service that supports Redis and Memcached. Its primary role is to speed up applications by caching frequently accessed data, so your application doesn't have to query a slower database every time. Think of ElastiCache as a performance booster that sits in front of your main database. Key ideas to remember: it delivers microsecond-level latency, making applications extremely fast. It's fully managed, so AWS handles patching, scaling, and failure recovery. It supports Redis, which includes advanced data structures and replication. Memcached, which is simpler and optimized purely for caching. Redis-based ElastiCache can support multi-OS failover, improving availability. Common use cases include user session storage for websites, caching database query results, gaming leaderboards, real-time counters or metrics, accelerating APIs and web applications. Important exam concept: ElastiCache is not designed for permanent storage. If all nodes fail, data can be lost. That's okay because cache data is usually rebuildable. Now let's look at Amazon MemoryDB for Redis, which is often confused with ElastiCache, but serves a different purpose. MemoryDB is also an in-memory database, but it is designed to be durable. That means it can safely store data long-term while still offering microsecond performance. MemoryDB achieves this by replicating data across multiple availability zones, maintaining a transactional log, automatically recovering data after failures. Key points to remember. Fully Redis compatible. Multi-OS durable storage. Handles millions of requests per second. Managed service with automated scaling and maintenance. Can be used as a primary database, not just a cache. Typical use cases include real-time bidding systems, financial and trading platforms, streaming and event-driven systems, applications that require both speed and durability, systems where losing data is unacceptable. This distinction is critical for the AWS exam. Use Amazon ElastiCache when you need ultra-fast access. Data can be regenerated. You're improving performance of an existing database. You want caching, not long-term storage. Use Amazon MemoryDB for Redis when you need in-memory speed and durability. Data must survive failures. Redis is your primary database. Multi-OS persistence is required. Simple rule to remember. ElastiCache equals fast cache. Data can be lost. MemoryDB equals fast database. Data must persist. If you remember this distinction, you'll be able to answer most exam questions about memory-based databases confidently. Let's now talk about how AWS helps organizations move databases into the cloud. And the first, and most important service you need to recognize is AWS Database Migration Service, or AWS DMS. When companies migrate to AWS, they usually can't afford long outages. Their applications still need to run, users still need access, and data must stay consistent. This is exactly the problem that AWS DMS is designed to solve. What is AWS Database Migration Service, DMS? AWS DMS is a fully managed service that helps you migrate databases to AWS quickly, securely, and with minimal downtime. One of its most important characteristics is that the source database stays fully operational during the migration. This means your production system can continue serving users while data is being copied in the background. DMS works for relational databases, NoSQL databases, data warehouses, and it supports both, from on-premises to AWS, from cloud to AWS, and even from AWS to AWS migrations. AWS DMS operates using three main components. 1. Source endpoint. This represents the database you are migrating from, for example, an on-premises Oracle database or a MySQL database running somewhere else. 2. Target endpoint. This is the destination in AWS, such as Amazon RDS, Amazon Aurora, DynamoDB, or Amazon Redshift. 3. Replication instance. This is a managed compute instance that AWS creates to perform the migration work. It reads data from the source and writes it to the target. Once configured, DMS runs migration tasks that define what data moves and how it moves. One of the most important exam concepts is change data capture, CDC. Here's how it works. DMS performs an initial full data load from the source to the target. After that, it continuously captures ongoing changes, inserts, updates, deletes. These changes are replicated in near real time to the target. Because of this, applications can stay online during migration. At the final cutover, downtime is minimal, often just minutes. This is a major reason AWS DMS is so widely used in production environments. AWS DMS supports two major migration patterns. 1. Homogeneous migrations. This means the source and target engines are the same. Examples: from MySQL to MySQL, from PostgreSQL to PostgreSQL, from Oracle to Oracle. These migrations are usually simpler because schemas are already compatible. 2. Heterogeneous migrations. This means migrating between different database engines, such as from Oracle to PostgreSQL, from SQL Server to Amazon Aurora, from MySQL to Amazon Aurora. In these cases, DMs handles the data movement, but schema conversion is handled with help from another tool, the AWS Schema Conversion Tool, SCT, which you'll learn next. Now let's talk about the AWS Schema Conversion Tool, often called AWS SCT, which plays a very important role in database migrations, especially when you are moving between different database engines. AWS SCT is a desktop-based tool that works alongside AWS Database Migration Service. While DMs focuses on moving the data itself, SCT focuses on something equally critical, converting the database structure and code so that it works in the new target engine. When you migrate between similar databases, like MySQL to MySQL, schema conversion is usually simple. But when you move between different technologies, such as Oracle to PostgreSQL or SQL Server to Amazon Aurora, the database objects are not always compatible. That's where AWS SCT comes in. First, AWS SCT analyzes your source database and generates an assessment report. This report tells you which objects can be converted automatically, which ones require manual changes, how complex the migration will be, an estimated level of effort. This assessment step is extremely important because it helps you understand migration risk before you move any data. Next, AWS SCT performs schema conversion. It can automatically convert tables and columns, indexes and constraints, views, stored procedures and functions, triggers, data types. For many objects, SCT can generate a ready-to-use version compatible with the target engine. When automatic conversion isn't possible, SCT highlights exactly what needs manual rewriting. Another powerful feature is code conversion support. If your application contains embedded SQL, such as in Java, .NET, or Python, SCT can scan that code and help convert incompatible SQL statements. This saves a significant amount of manual effort during modernization projects. How AWS SCT fits into the migration workflow. Think of migration as a three-step process. Assess. Use AWS SCT to analyze your source database and understand complexity, risks, and effort. Convert. Use SCT to convert schemas, database objects, and SQL logic into a format compatible with the target database. Migrate data. Use AWS DMs to move the actual data and keep it in sync using Change Data Capture, CDC. SCT prepares the structure. DMs moves the data. AWS SCT is commonly used when migrating from Oracle or SQL Server to PostgreSQL or Amazon Aurora, converting Teradata or Oracle data warehouses to Amazon Redshift, modernizing legacy databases to open-source engines, evaluating migration feasibility before committing to a project, reducing manual effort and migration risk. For the AWS Certified Cloud Practitioner exam, remember this simple rule. AWS SCT equals schema and code conversion. AWS DMs equals data movement and replication. If a question mentions analyzing schema compatibility, converting database objects, or assessing migration complexity, the correct answer is almost always AWS Schema Conversion Tool.